Good morning, everyone. Thank you for joining us for the third of 4 webinars in a new series, using marine shoreline design guidelines to improve shoreline stabilization permitting. This webinar series is sponsored by the Shoreline and Coastal Planners Group and was developed by Washington Sea Grant, Washington Department of Fish and Wildlife, and Washington Department of Ecology. First, some logistics. We have disabled participant microphones, so if you have questions, please type them in the chat box that you'll find at the bottom of your screen. You can open the chat box by clicking on the chat icon shown at the bottom. We also have some materials available for download that we'll be referencing during the webinar and that you can use for yourself following this webinar. The materials can be found in the reminder email that you should have received and on the Shoreline and Coastal Planners Group website shown at the bottom of this slide. We also have some useful links available at this website. And a note, today's webinar is being recorded. Recordings and slides of all of our webinars will also be posted on the Planners Group website. Today's webinar will be taking a more detailed look at the various shoreline stabilization techniques used in Puget Sound, and we'll examine how the Marine Shoreline Design Guidelines, or MSDG, can inform the review of projects proposing these techniques. We will also review an MSDG-based tool to examine the level of risk at a site and how that relates to selecting an appropriate technique. Finally, we'll take a step back and examine other elements of a project design that you can look for when reviewing a project. And throughout the webinar, we will provide examples along the way. Today, you'll be hearing from 3 speakers. I'll start by introducing myself. I'm Sydney Fishman, and I am the Shoreline Armoring Planning Associate at the Washington Department of Ecology. Now I'll let our other 2 speakers introduce themselves, starting with Nicole.
Hi, this is Nicole, Shoreline Coastal Planner with Washington Sea Grant.
And Corey.
And this is Corey. I'm a habitat engineer with the Washington Department of Fish and Wildlife.
Excellent. So before we get into any new content, let's quickly review what we covered in webinars 1 and 2 in case you weren't able to join us. In webinar 1, we gave a high-level overview of key concepts related to shoreline geology and processes, and we also gave an overview of the state and federal permitting environment. In webinar 2, we examined some key elements that make up a site assessment for understanding, for example, what's happening with the site's soils, wave climate, and beach sediment. We connected those on-the-ground characteristics to a determination of risk at the site and how that feeds into a demonstration of need in the regulatory review process. We also covered a variety of tools that you can find in your reminder email and on the Planners Group website, including a site visit checklist and a geotechnical report review checklist. We also provided a glossary of key terms and the cumulative risk tool that we'll be coming back to today. So if you attended webinar 2, this graphic may look familiar. It outlines the mitigation sequence in shoreline master programs for jurisdictions to achieve no net loss of ecological functions as they permit shoreline projects. Last webinar, we talked about avoidance, and specifically avoiding bulkheads that are not necessary. This is the crux of demonstration of need. In order to issue a shoreline exemption for a bulkhead, there needs to be evidence of a primary structure at risk and evidence that shoreline stabilization will address that problem. Next in the mitigation sequence is minimizing impacts through the use of the least impactful method feasible. If shoreline stabilization is going to occur, the project should minimize impacts through its design and construction techniques. This relates to the alternatives analysis found in comprehensively updated SMPs, so only permitting hard armoring if passive or soft approaches are infeasible. Corey is going to talk in much greater detail about that spectrum of techniques and explain a tool that we've developed based on MSDG. So I'll pass it off to Corey now.
Thank you, Sydney. Let's take a look at those techniques that the guidelines discussed. These are in chapters 6 and 7 of the guidelines if you happen to be kind of following along. Now, as I run through these individual techniques, I'm going to try to make some general comments about the costs, the complexity, and the benefits and potential detriments for the subject techniques. And also, I'll be showing a few examples of how these techniques are used and how they can be used well, and potentially how they could be used not quite so well. So after we run through the techniques themselves, Sydney, I'll jump back to Sydney. She's going to run through some information about a cool tool, and then we're going to help take a look at how we determine what the appropriate techniques are. So our occupation or our use of the shoreline often results in the insertion of additional water into the bluff from sources like our septic tanks, storm drainage, irrigation, or just by increasing the runoff by replacing porous surfaces like vegetation with impervious surfaces like roofs or roads. So unfortunately, this additional water tends to go along with the removal of tall trees and brush off the top and upper slopes of bluffs, and then additional loading also, right? We put things onto the slope that load that and make it a little less stable. So the range of techniques that we're going to talk about today starts off with passive techniques that don't really actually aim to do a whole lot to the shoreline, but really more just manage that additional water that we put into the slope. So passive techniques, they're defined as those techniques that don't actually interact with the shoreline much at all. So they're the least impactful on the shoreline, and for the most part really don't require a lot of difficult engineering or construction techniques. These techniques include planting, implementing drainage BMPs, and then the relocation and removal of infrastructure. This is chapter 6 in the guidelines. And the big emphasis really is on getting the water out of the slope as possible without breaking a lot of ground or doing a whole lot of complicated engineering. So starting off, here's an example of what some of the stormwater drainage techniques, stormwater drainage management techniques look like. An example of a T diffuser, or what the Stormwater Management Manual for Western and Eastern Washington calls a level spreader. The idea here is that they've concentrated the water further up the slope and piped it down closer to the beach to keep that water out of the slope, keep it from saturating and weakening those soils. So another technique that's common at these locations, like this specifically, is where we have this concentrated high energy flow, we add something to dissipate that energy. So in this case, we've got the T-spreader that you can see there, the black pipe, that's sitting on top of a couple Gabion baskets that are full of quarry spalls, which actually is going to absorb the energy of the water coming out of that T-spreader before it can act on the beach or the slope behind that beach. So here's an example of a similar approach that wasn't quite as well executed. Here we see the property owners concentrated their surface waters and dumped that right out at the toe of the bluff. And you can see how that lack of energy dissipation is actually causing some erosion on the beach on kind of the right side of the photo there. And then as a result, we get some subsequent scour on the slope behind that location where the outlets were, and the slope is beginning to fail. So moving on, the next technique that we discuss, along with managing your stormwater, is vegetation management. And in the case of the photo here, there's a bunch of clearing necessary to allow access from the uplands to do a restoration project, in this case removing a bulkhead. The majority of the clearing did happen to be blackberries, ivy, and hawthorn, so we didn't feel too bad about doing more of a wholesale removal. But regardless, we ended up with this somewhat expansive bare terrace that we needed to take care of as accumulating rainwater and had some potential of some issues there. So we took a relatively aggressive approach to planting. We planted a pretty good range of plants to help reduce the energy of that falling rain and to help aspirate moisture out the slope, provide a little bit of root structure. And that's all to say nothing about the habitat benefits that came along with the planting and hopefully ultimately the success of those plants. So we did mulch shortly after the planting to provide another physical barrier for the season or two before plants really get established. And next we look to a less successful example of this. where we had a berm constructed as protection from rising tide levels and a changed bathymetric condition. Vegetation was clearly quite poorly managed. In this case, the berm was planted aggressively. However, the project proponent and landowner didn't coordinate well enough to prevent all of the native plants that were planted from being choked out by Scotch broom that came in. And then the third option here under passive techniques is relocation. It doesn't always necessarily involve putting a house on the back of a Mack truck and driving it down the highway, though. So similar to a no action option, relocation should always be considered, especially if the scope of other alternatives appears to be approaching some pretty high costs, or even if hard options don't appear to really solve the problem. So the kind of as a contrast to the other techniques we touched on earlier, the costs for relocation tend to be a little bit higher. But considering average bluff recession rates and the time that you gain with a relatively minor relocation distance, it can actually be a little bit more palatable of an option. So this option is passive. It's virtually impactless to the beach. However, it does require a little broader range of expertise. People such as geotechnical engineers, civil engineers, structural engineers, and even a pretty specialized suite of construction techniques and equipment could be necessary. Really, the critical information is that you need a suitable location for receiving and a landscape that can facilitate that relocation. That's what's kind of drive the applicability of this technique. And one more note on passive techniques. These really should be included in pretty much any other type of design, whether that's restoration, soft or hard techniques, which we'll talk about as we go. These options, with the exception of relocation, are pretty darn cheap, and generally they're actions that support good stewardship of the shore. So the benefit of these is that they work in pretty much all settings and can be performed in advance of pretty much any other options, and you can add in some of these options as necessary. There's virtually no locations where they don't work, and a better way to put that might actually be to say that there's locations and settings where passive techniques shouldn't be the only solution. So we'll move on to soft techniques, what you might call soft shore techniques. This category includes armored techniques that aren't hard, should be implied with the name. Soft shore protection it's actually kind of a range, and it's somewhere between hard armor that is monolithic, doesn't allow any movement or beach bluff dynamics, and no protection, like the passive techniques that I just touched on. So it's kind of in between those two design type options. So it's a pretty broad spectrum. Techniques that can be used in conjunction to form either a very natural soft solution or a pretty stiff man-made solution, and kind of all fall under that same soft moniker. So the important thing to emphasize here is that while soft techniques tend to use natural materials and allow minor adjustments, the ultimate goal here is still to impede that process that forms and sustains our beach habitats. So they still are intended to protect the shore and slow or otherwise impede the drift process, or if you don't happen to be in a drift aligned location, which we touched on earlier, the shore dynamic there. So just happens to be to a lesser extent than hard armor and with natural materials. So there's a lot of potential names for soft shore protection. One of the most common that we hear is living shoreline. And I wanted to caution you regarding the language living shorelines and the guidance that's developed for that, because it really is developed in a different location, for the most part in the East and Gulf Coast, and which is a lot different beach dynamics than we have in Puget Sound. And we really don't know how those techniques will work in an environment like Puget Sound, where our beaches are mostly gravel dominated, without these really long, broad marshes and oyster reefs, and with very different fetch conditions and much different wave dynamics. So there's a lot of overlap in the techniques, but a lot of the concepts that fall under the living shorelines umbrella aren't really necessary for use in Puget Sound. So that said, let's look at the soft techniques that we have in the guidelines. So we'll start with beach nourishment. Beach nourishment is covered in Chapter 7.1 of the guidelines. It's a pretty straightforward technique. It's really adding gravel, sand, and potentially some cobbles onto the beach to temporarily or for some longer term reestablish the beach grade and provide some potentially sacrificial material to slow the beach or bluff recession rate. This idea ultimately came from techniques that are used more in open coastal areas like Florida and some of those bigger, broader East Coast beaches, where sand would actually be gathered offshore and then dumped back onto the beach to maintain a nice beach profile for people to hang out on. You tend to hear that referred to more as beach renourishment. And if you've read the guidelines or have a lot of interaction with Jim Johansson or Hugh Shipman, you'll know that these the pioneering techniques of beach nourishment on our shorelines in Puget Sound were done by Wolf Bauer, and many of the projects that form the background basis for the guidelines are his old projects. So here's a little more typical type of beach nourishment installation. Ideally, the materials that are placed on the beach would match the existing beach gravel size, or if there happens to be if there's no forage fish concerns and there's a bluff there, you might even consider matching the size and gradation of the soils in the bluff, identifying and figuring out what those look like. If you're matching those techniques, can be as easy as doing a pebble count or taking a sample and doing a gradation on that sample. So this technique can and often is used as an analog to beach sediment source. And can be used as a mitigation measure when hard armor is reducing the sediment delivery to the beach. Fish and Wildlife has some provisions for the gravel gradation for forage fish. And there's some guidance in Chapter 7.1 on the recommended gravel sizes, specifically what should the D50 of your sediment size be in relation to the wave energies that you have at the site. So the quantity, the alignment, the extent, tends to be very site-specific, and it depends a lot on the necessary protection and the expected wave dynamics. So the sites that require more protection oftentimes will need a core or a little bit more robust, larger material that's a little more stable at the base or kind of internal to that beach nourishment with that little bit more deformable, more natural stuff on the outside. So beach nourishment tends to be relatively low cost. It has a lot to do with the availability of the appropriate materials, the access to the site, and how often you might have to re-nourish. So it's a good comment to emphasize, if you're putting beach nourishment on a drift-aligned beach that has moderate to high energy and a reduced source of drift materials, you'll probably need to come back and add more sometime in the distant future. So a word of caution on beach nourishment. We generally recommend avoiding this as a primary or a single technique where you've got high energies. So in the case of the photo here, photo on the left is pretty much right as construction was finishing up. The photo on the right was, I believe it was within a couple weeks that we had this event. And ultimately we ended up having to modify the design a few times and renourish a few times just because the energy was not quite right. So to note, particularly look at the slope on the photo on the left and the size of the sediments there. You can see it's relatively fine and there's a relatively gradual slope. And then on the photo on the right, which is just a few weeks later, we had much larger materials. The slope is much steeper. We can see that a lot of those materials have disappeared. And a note, if you had used the checklists and the tools that are in both the guidelines and that we're making available to you guys, you'd probably come to a different conclusion for this site. And then the next technique here is large wood. Chapter 7.2 covers large wood. Generally, it's a great technique to naturalize a beach and provide some stability to a over-mobile beach. Wood ideally gets placed well away from a steep bluff and gets placed on a back beach feature somewhere between 1 to 2 feet above the mean high water line, which is where wood will naturally tend to recruit. These logs can function, they can function as drift sills if they happen to be installed at some skew to the beach, and they can be anchored or countersunk a portion of the diameter of that log, and in more robust and those less natural type of installations. So On bluff-back beaches, an area where there happens to not be any beach, and then also in bedrock and clay beaches, placing wood doesn't necessarily have a very good retention. We tend to see those logs kind of float up and drift away, and nor do we see a really good stabilizing effect or storage effect on the mobile sediment moving through the system. So wood that's placed too low on the beach tends to interact a little bit too much with water, or if it's anchored heavily and it's too low on the beach, it can have actually kind of the inverse effect on the stability of that beach. Most wood on Puget Sound beaches tends to be cut logs without branches, but in order to gain the most stability, the most ecological benefit, we want to see the biggest logs you can have with branches and roots. That'll maximize both benefits. Another type of installation here, we see a little bit more robust. It's anchored, it's placed in a little bit higher energy setting. The function here is really more to release energy rather than try and store sediment or have any kind of that drift sill type function I mentioned. Sites with high energy, like I mentioned, can be a little bit problematic with wood and likely will require anchoring. Large wood additions to the beach, particularly if they're anchored, can be low to moderate cost, just because gathering, transporting, and placing large wood can be a little bit difficult depending on access to the site. And then we'll take a look here how wood can potentially function poorly. I touched on this earlier. We see that in this case, the wood's been placed a little bit too low on the beach. It's been anchored, it's been placed in a high energy setting. These are all less ideal conditions for successful use of large wood in the absence of any other technique. We almost immediately saw scour of the areas between the root wads. And you can see on the photo on the right there, it's a little bit more clear how quickly that material is disappearing. The logs, they got too many high energy waves. They couldn't adjust, and so the energy was actually kind of aggravated and expressed itself more on the bluff than on the wood. And so we saw material mobilizing. And really the slope that was supposed to be protected by these root wads and logs ended up getting chewed away at a little bit higher rate because of the wood. And then the third technique, I believe I'm on number 3 here, is resloping and revegetating. Chapter 7.3 covers reslope and revegetating. Technique is really exactly what it sounds like. Got a question here. I'm going to hold that question until I get to a little bit better pausing point, but I'm going to keep rolling. It's exactly like it sounds, reshaping the slope at risk to a shallower and more stable slope, and then aggressively planting to minimize the chances of any slope failure. Other than the physical benefit of moving the top of the slope back and allowing vegetation to develop roots and further stabilize the slope, the technique potentially allows the designer to access a stronger and more stable layer of soils that underlies the superficial materials that might happen to be less stable. And it allows you to potentially manage the effect of water that could be running along that interstitial layer. Planting is critical to the success of this technique as it provides stability and benefits in numerous ways that we've touched on. The plants, again, should be native, should be strong-rooted and pretty resilient. And like I think I've said this before, is that we tend to recommend a blend of larger trees, moderate brush, smaller ground cover, and shrubs, so that you get kind of all ranges of protection. So real quick on the question here, in situations where you find the design failed, needs to be redone, where does the funding come from to do so? What's the probability of this kind of design failure? And specifically, what is the risk of failure to Shoreline, to the landowner? I guess in my experience, the funding tends to come from it comes out of the project, essentially, and we've had to potentially truncate the project because the failure has potentially come to the point that it needs to be fixed. And then what is the probability of the kind of design failure? That is kind of, it relates to the risk that we talked about in the previous webinar. We're always at risk of failure because we could always get one of those very, very low likelihood events, the 1% tide with a 1% storm type of thing. So that really ultimately drives the probability of that type of failure. And what is the risk of failure of success to the landowner? again, I guess I'll defer to, it has a lot to do with specifically where is your site in relation to the shoreline, and how, and again, where do you land on that risk? So looks like we're getting a bunch of questions here on logs. Let's see here. It looks like the paired logs actually got buried. Not sure that that was a bad thing. And wouldn't that help to collect and stabilize material? Are there studies document where it was found on different grain sizes and energy beaches? I'll start on the top. The burying of the logs isn't necessarily a bad thing. The issue is that they happen to be too low on the beach and buried. So they're essentially anchored. They couldn't move. And so when waves would interact and hit those logs, they would stay there and concentrate energy in between them. So that was the issue, not necessarily that they were buried or anchored. It happened to be the anchoring and the location. And I can't say, let's see, studies to document where wood is found on different grain size and energy beaches. I'll say tentatively yes. I'm aware of some studies that have documented the locations of wood and densities of wood. They tend to be more site specific, you know, how much wood do we tend to see in specific locations at where at. I don't know that it's necessarily been tied to beach grain sizes though. And then let's see here, one last question, LWD, what's the long-term impact of anchor chains? I'm going to reserve, I can't necessarily say. I know that there's been some pushback to using galvanized materials because of the potential for potential biological impacts of that galvanizing. And I generally avoid non-natural materials for anchoring just because when the wood goes away, disappears, you know, wood tends to have a lifetime of about 15 years. We still have these metal things laying on the beach, and I'm not a huge fan of those. Let's see here. One more quick question here. I really should save these until we do questions, but since it's in front of me. How do we get past the geotech and bulkhead industry's hesitancy? A great question. And I think the approach thus far has been to somewhat mandate that with code. We're seeing resistance to the traditional three-man rock bulkhead with code requirements and requiring mitigation. And then, but that's about as good as I can say for that. So I mentioned planting. Your Marine Waterfront document that we brought up, I believe that was the first webinar. It's got a lot of pages and information about selecting native plants for shoreline projects. And it discusses things like trees, shrubs, perennials, ground cover plants. And we do have a link to this on the Planners Group website, which is at coastalplanners.org/webinars. So moving on, a couple examples of reslope and reslope and replant. We can see here a contractor reconstructing the slope in this location, and subsequently the replanting. Maybe, there we go. The site, in this case, it happened to be a pretty low energy site. And so we ended up not putting a lot of big trees. Also due to the road being very nearby to that slope, larger trees were unfavorable. So depending on the level of risk and necessary stability, you can use things like erosion control devices to help in the interim. Plants, grasses, things to help in the interim as those plants and grasses are being established, preferably with natural materials that break down, things like jute and coir or hemp. In the long term, if you have less confidence in the ability of those plants to stabilize, there are the options of synthetic materials. I would say bear in mind that you're adding plastic to the shoreline, and just keep that in mind. We try to avoid that. So resloping and revegetating, generally very cost-effective approach. However, in high slopes and long lateral projects that have a lot of slope that needs to be fixed, the increases of cost actually go up relatively quickly. I'm going to hold on to for questions because I think we're going to hit on a few more things and then have another break. So I might wait on those next couple questions until we get there. So this section, so it gets lumped in with all of the techniques, with soft and hard techniques. And it really, I like to think it could ultimately end up in a separate category, but being really just one single technique, which we'll touch on when we get over there, we're going to put it in right here. It is in chapter 7.4 of the guidelines. So let's go ahead and move ahead. This technique, it just includes bulkhead removal. So not necessarily soft or hard, more restoration type technique. This is discussed in chapter 7.4, and it's a relatively light section in the guidelines because the technique itself doesn't really require a lot of prescriptive guidance. Just go take something off the shoreline. Rather, it requires a good understanding of the processes and the shore dynamics at a specific site, which is what we talk a lot about in chapters 3 and 4 of the guidelines. So special attention has to be paid to the risk of removal, to the subject site, and to the adjacent properties. Wave reflection and end effects aren't necessarily apparent when transitions from property to property are smoothly armored. And we'll take a look at what can happen with those end effects in wave translation. So when you remove a portion of that bulkhead, you can have some pretty ugly effects. An example here, we see where the bulkhead has been ended. I don't know if this was actually necessarily a removal, but where a bulkhead was installed and then abruptly stopped without a really good, robust return to help mitigate the effects of that wave reflection. We can see that the bluff on the adjacent beach downdrift is actually receiving the brunt of that wave energy and has started to recede much quicker and is actually starting to recede back behind the bulkhead there. And so moving on, I struggled to find a good example of a poor bulkhead removal. So the photo you see here is actually a location where a landowner that lived right next to a project we were doing, had offered to let his bulkhead be removed and use some soft techniques. And unfortunately, as I hope you can see, the home is pretty low in the intertidal in that diurnal range, and it's pretty close to the shoreline laterally that happened to be a relatively high energy shoreline. So in conjunction with managed retreat or some very, very robust beach nourishment and maybe some wood, this project might have been a pretty good achievable project, but it would have required a lot of renourishment, and it would displace a lot of intertidal habitat to build enough beach kind of out at the front of that property to prevent damage to the home. So in this case, we opted, we're going to just leave it as it is and not take advantage of that potential opportunity. Not a great example of where it ought to be used. And then the last technique we discuss is hard armor. And I'd offer a consideration for hard armor. If we use it to prevent a slope from feeding the beach, a bluff or a slope, and that slope happens to be constructed of something that we really don't want to end up on the beach, a road, a house, or contaminated soils, we might be a little bit more accepting to this type of alternative. That said, I'm going to skip the impacts because we've discussed those pretty thoroughly in the previous two webinars. They're discussed very well in the guidelines, and I feel like just the group that we happen to be speaking to is pretty well of the repercussions of hard armor in the wrong location. So I'll be pretty brief because these techniques aren't necessarily quite as desirable. We discuss hard armor in two separate types in chapter 7.5. Bulkheads, which are vertical walls made out of really anything that's hard, I guess, like stone. I believe that's cemented stone on the photo on the right. And then revetments, which are armor that's sloping, slopes off of a straight vertical, which is like the photo on the left there. So these approaches are necessary in high energy, high bluff, and high risk sites, or at sites that happen to be have critical embedments in the slope, things like contaminants or culturally sensitive items. So let me restate, they should include a pretty robust engineering design and should come along with a really good understanding of the processes and shore dynamics that are going to be impacted by the project. So the results are like we discussed in the previous days, the interruption or potential impeding of that process. So understanding that's very critical. And I'm going to leave the discussion there. Let's see here. I'm going to just see what questions we've got, anything I can answer relatively quickly. So lots of great work from Shore Friendly coming to Pierce County to change attitudes about the use of armor. Absolutely. I suppose that's probably the best response to the previous question there. Bridget Reynolds, do you have any examples of good code language mandating soft shore techniques? I don't, not off the top of my head. I'll defer to other folks that work with other codes. The code that I work with is pretty static and it's hard to change. It being the hydraulic code, so I'll kind of leave that one there. Based off of the use of wood to help stabilize the shoreline, would it not be best to convince to leave wood that shows up naturally rather than remove them? Absolutely. I agree with that 100%. Unfortunately, you know, a woody beach has the perception of being messy and unclean. Hopefully we're getting away from that attitude and mindset. Yeah, and it looks like that covers it. I'll leave the discussion there, and I'll pass the lead on to Sydney here to discuss the tool to see how these projects are applied and what they look like.
Great, thanks, Corey. And just before I jump into my section, just to respond to Bridget real quickly, I know Anna just dropped a link there to Island County's, I'm assuming SMP, and more broadly, WAC 173.26.231, which is all about shoreline modifications, specifically outlines the range of measures that vary from soft to hard techniques. So everything that actually would be more considered passive, like vegetation enhancement and upland drainage control, all the way to bulkheads and seawalls. And so pretty much in every comprehensively updated SMP, though it might vary slightly by jurisdiction, you should see some kind of list like that, or a discussion that homeowners need to consider that range of alternatives. If you have further questions, feel free to drop them down there if you are considering a specific jurisdiction. But in general, you should find that in your SMP. And so I'm going to move on now and talk about and give a quick overview of an online resource developed by the Department of Ecology in conjunction with lots of partners, including local and state agencies, tribes, nonprofits, academic researchers, and private homeowners, to highlight different soft shore and other alternatives to armor projects that have been done on Puget Sound beaches. And the link to this tool is on the Coastal Planners Group website. And so here's a screenshot of this web application that was launched in August 2019. It's called Examples of Puget Sound Soft Shore and Armor Alternative Projects. And we hope this resource will serve to document the work that's happening in our region to reduce and remove hard armor. And we also want it to be a resource that folks like local governments can use to illustrate successful projects to potential applicants. So currently it shows 59 projects, and each season as construction occurs, that number is going to grow. And a shameless plug, I personally manage this web application. So if you know of any projects, please reach out to me to consider adding them. My email will be shown at the end of this webinar. Now I'm just going to give a quick walkthrough, show some screenshots of how to use this tool. So when you first visit the link, you get a splash screen with some information about the tool, how to use it. Go ahead and click OK. And then you hit the main screen of the tool, which shows all of the projects that we're featuring on Puget Sound and also the Strait of Juan de Fuca. You can click on any of these points and a pop-up window comes up. It has some basic information about the project and you can scroll through to read more. You can also expand that window to see all the attributes at once. So we have information about the project sponsor, the year it was completed, and if certain actions occurred like beach nourishment or armor removal. We also have links to 2 photo resources. So that first link goes to the Department of Ecology's Shoreline Photo Viewer, where you can see the oblique aerial imagery for the site at several points over the past decades. This is what the Shoreline photo viewer looks like when you follow that link. And this is just a great resource overall for seeing changes on the shoreline over time. So I encourage you to check it out if you're not familiar with it. The second photo resource that it links to is a Flickr album that we've put together showing before and after photos for these sites. So when you click on those links or you go to the main album page, this is what you see, but the links in each of those pop-up windows actually take you right to the photos for that specific site. Currently, we have 129 photos, so unfortunately, I can't show them all to you, but do check it out. There's a link also directly to this Flickr album on the Planners Group website. And here's just one example of the types of before and after photos that you'll find on Flickr. This is the southern end of Seahurst Park, where they removed fill, gabions, and rock armor at the toe of a bluff, and then did beach nourishment and revegetation, and it was completed in 2005. So we have similar photos for nearly every project that's featured on the tool. So back to the tool itself. One other feature of the tool I want to highlight is this suite of widgets at the bottom of the screen, which are outlined in red. You can click on all of those, but two that I specifically want to highlight are shown expanded here. The one on the left is a layer list. So each of these can be turned on and off by checking the boxes to see projects where a specific technique was used. So if you only want to see projects where armor was removed or beach nourishment was used, you can turn those on and those projects will pop up. And then on the right, you can filter by geomorphic setting. So only seeing projects that occurred, for example, on a bluff or at a stream mouth. So this is great if you know the geomorphic setting of your site and you want to see similar examples. So I encourage you to play around with the tool, and if you have any feedback, you can submit it to me. There's actually a survey link at the top of the main page of the tool. You can click on the black icon that looks kind of like a paperclip, and then a drop-down menu where you can provide feedback, or you can simply send me an email. Also, again, shameless plug, please email me if there are projects on Puget Sound or the Strait that you'd like to see added. Really always trying to collect new examples and highlight the great work that's being done around the region. So with that, I will pass it back to Corey, and I'll just save any questions for the end. So Corey, take it away.
All right, let's run through an example, how you might use the cumulative risk tool that we touched on last week, and use that with a tool that I'm going to show you right here. So here's a table for alternatives analysis, and it's essentially the techniques selection, like it says on the top of the sheet there. Really, it's going to drive what techniques are considered appropriate based off of the guidelines approach. So there is a decision tree that ultimately will get you down to the same result. But it's a little bit bigger, it's a little bit harder to follow, and it's kind of hard to see on a smaller screen, which we kind of assumed you guys would be watching on. So the process is pretty straightforward. You've determined risk, you've determined wave energy on your site, and then the shore type, which you gather in the checklist, or the site assessment that you would gather if you fill out your checklist. Doesn't have a huge amount of bearing on the applicability. If you look on the shore type section, there's a lot of alls there, but you already determined that. So there's a table in the guidelines that describes backshore width categories, which is kind of that next item. It's a little confusing, but I'm going to walk through this process here. So that's the information you'll be needing for picking a technique. You'll see that going through the process, you'll probably end up with a few different techniques, which is absolutely appropriate. So let's take a quick look at the tool first. So here's the cumulative risk model and the appropriate techniques table, along with the wave energy and the categories for backshore width. That's all being made available in the attachments packet, which is, and then one more reminder, I guess you can download those off the Planners Group website. So let's take a look at that example. Let's look at Burfoot County Park. We're going to run through, we're going to take a look at pictures there. It's in Thurston County on the northeastern edge of the mouth of Budd Inlet. Our prevailing winds are from the south here and pretty much straight from the state capitol. And the site is a bluff-backed accretion shore form. So here are photos of the existing site conditions. You can see we've got an accretion shore form with a bluff backing it, but the structure and the existing bulkhead and the road are all kind of in front of the bluff on that accretion shore form. So we starting off, we'll start with our cumulative risk. We go to the table, we select our shore type. It's an accretion shore form, so we get a 1 for that score. Next, we move to the wave climate at the site. Looking at Boston Harbor there, we know from the previous slides that the prevailing winds are from the south. So we go to our fetch score and we select the correct range, which is, you can see there it's 6 miles, so we're between 5 and 15. We get a score of 3. And then the next category here we take a look at is the setback of the structure. So the setback we see that we'll call the road, our structure here, and it's about 13 feet from the top of the shore armor to the shoreward edge of that road. And then based off of that measured setback here, we get the appropriate distance range. We see that that is the smallest category, which gives us a result of a 4, the highest score for the setback. And then onto the last category from an aerial here, and then from the photos we saw, we know there's no structures on that site. There's a road, there's no infrastructure. So we select a 1 for our infrastructure type score. Now, moving on, we compile all that information. We'll start with our erosion potential score. We have a 1 for the shore type, a 3 for the fetch, and our erosion potential score is a 4. And then moving into the infrastructure threat, we have a 4 from the setback, and we have a 1 from the infrastructure type, and we get a total of 5. So finally, we calculate our cumulative risk by multiplying that erosion potential and the infrastructure threat score. And you see we get a 20, which puts us kind of smack dab in the middle of moderate risk. And one note, pretty much all the information that we've gathered would have already been done had you been going through the checklist that we've got prepared for you in the site assessment. That we discussed in the site assessment either last week or 2 weeks ago. One of those. Must have been last week, yeah. So let's pull up that alternatives analysis worksheet that we showed at the beginning. And here we go. So we can see all the information here. The table on the left shows us that we need our wave energy. I've already highlighted the risk that categorizes to what we just calculated. So we need our shore type, we need our backshore width in addition to that risk. So the table on the right shows you how to get that. And so we're going to kind of step through that. We have our wave energy. So we see that we are in that high wave energy category. So we look to the wave energy category, and I'm sorry, getting a little repetitive here. So I've circled the high energy category and the shore types that are appropriate. We take a jump here to the backshore width category. We start, the way we use that tool that we've got there, we start with the wave energy category that we just figured, and then we look to the column that corresponds with that wave energy. And then we see this series of, within that column, we see the series of distances, setbacks, and that's in feet. And so we pick a setback at our site that matches or fits into one of those categories. So from our cross section we looked at earlier, we know that the setback distance will be the same as the backshore distance because the backshore runs right into the subject structure. And we've got a 13-foot setback, so we see that puts us in the low backshore width category. Again, in the high wave energy category, we have 13 feet, which is less than 25. And so we zoom over to the left there and see that we're in the low backshore width category. So I've circled those, the approaches that have that appropriate backshore width on the selection table there. And we see that the risk isn't quite high enough here to justify hard armor, but the conditions really aren't such that protection with soft techniques would be very successful. So the recommended techniques here are all restoration passive and no action. Now, what would drive you to a different solution here would be if there were a little bit higher risk, if there happened to be something on the site that justified a higher risk, a building, a house, or any infrastructure. If that were the case, it would probably be kind of a no-brainer for hard armor, just given the energies and the lack of setback at that site. So again, one more time, I'm going to keep plugging our products here. We prepared that site assessment checklist that we talked about last week. that drives pretty much everything that we just ran through. So I'm going to hand it off to Nicole to chat about some additional checklists for assessing designs.
Thanks, Corey. Okay, so now you know about a lot of different techniques and how to determine what is appropriate technique for your site. We want to take a step back and we want you to think a little bit more broadly about the site. And there's so much more to a project other than just whether or not there's a bulkhead and what's happening right along that shore edge. So we want to introduce you to a checklist we've made available to you for assessing designs of the entire site and some issues that you might want to be considering in addition to the bulkhead. So let's jump from techniques into this design checklist. And this is very high level, and it's a way to look at what we've been talking about so far. It's a way to assess whether a project has addressed this broader range, and it can help with conducting your alternatives analysis and place emphasis on how you can minimize impacts and maximize some of the benefits of your project, making it much more holistic. And as a planner, you can influence design using this checklist with your homeowners, encouraging them to make improvements. So we'll start with looking at all the different issues. There's the 4 topics that we're going to address are habitat, and shoreline processes, habitat, water quality, and community use, shared access, shared activities. So we'll start with looking at those issues related to shore process. And some of these will repeat things that we've already been talking about. So when you're evaluating the site, one of the first places to start is determine, is it possible to avoid shore protection altogether? Has the design avoided bulkheads or groins or other shore protection, and can that be accomplished? And using the risk tool that Corey's talked about can really help with determining this. Then does the design for the existing proposed buildings and other major improvements, are they set back far enough from the shoreline or the bluff crest to avoid the need for shore protection over the life of the improvements? Next, consider, is it possible to reduce or remove an existing bulkhead? This again, from the site assessment tool, it gives you great information about whether it's an option. So go back and review what you've either provided or been presented with your assessment tool to determine this. Look and see whether there's any groins on the property that could be removed. These are those structures that might extend perpendicular to the shoreline and impede the sediment. Using the site assessment tool and the risk tool, as we've been describing, you can determine if soft shore protections is the appropriate alternative based on everything that Corey's taught you. You're all now experts at figuring that out. Are there options for the existing structure to be moved back from the water to help prevent the shoreline erosion problems? Corey touched on this a bit, and this is something that we will be talking again more about next week with our conversation about armor and sea level rise. The next area that we talk about and want to consider is shoreline habitat. So look and see if the project has either maintained or replanted native vegetation to preserve and conserve the shoreline. Are there trees or snags that can be preserved along the waterfront to provide stabilization? Is there an opportunity to remove on the site any invasive species and noxious weeds? And are there opportunities to include the use of large woody debris? This was one of the design solutions that Corey talked about. The third area to consider relates to water quality issues on the site. There are a number of issues to be asked about a site when it relates to water quality. So for example, when evaluating a site, has everything possible been done to minimize the amount of disturbance during construction? And this can make a big difference in the amount of runoff that enters marine waters during construction. What about, another question is to ask about whether the project can minimize the amount of impervious surface, using low impact development and looking for other ways to reduce the quantity and the treatment of surface water runoff from the site. Well, what about options to remove creosote? Creosote treated wood leaches into the marine waters and should be removed wherever possible. So looking for those opportunities with all projects is important. What about the use of herbicides and pesticides? Does the project have a landscape management plan? Can you determine whether these harmful chemicals will be reduced on site? Some local plans and some local planning processes actually require the use of the overall site development and include a landscape management plan. And this is an opportunity when you can look for to address these types of issues. And finally, what about the type of on-site sewage and where is it located? Trying to make sure that it's being located as far as possible from the shoreline, and this to avoid potentials for contamination, which again becomes more and more of an issue with sea level rise. And then the final and fourth areas relates to this opportunity for shoreline stewardship. For example, if you can ask whether a project that are there opportunities to be collaborative with your neighbors? So for example, if a dock is being proposed, is this something that could be considered for a group of homeowners? A shared asset that would reduce overwater impacts is really a critical opportunity. So the design checklist is a handy little tool. Again, it's part of the handouts we're giving to you. And it's a way to look at whether the design or review of project, you can look at these larger set of issues. And you can find this in the packet, the handout packet that we gave you all for the webinar. And it also is on the Coastal Planners website at coastalplanners.org/webinar. And there's right under the title, there's a link for handout and then a link for resources. Okay, now I'm going to turn it back over to Sydney.
Great, thank you, Nicole. So now we're going to open it up for questions. We've already gotten some fantastic questions that we've touched on earlier, and I know some other ones have been added to the chat. So if you have a burning question and you haven't sent it to us already, please go ahead and type it into the chat box. And while you're all thinking, let's give you a reminder about our fourth and final webinar. So webinar 4 is going to be held next Tuesday, March 3rd at the same starting time of 9:30 a.m. And it's going to cover shoreline stabilization in the context of sea level rise. So I know we've gotten several questions about sea level rise in our earlier webinars. Nicole was just mentioning it as part of your overall site consideration. So hopefully you can join us and continue this discussion. If you're not already registered for webinar 4, we encourage you to visit our website, coastalplanners.org/webinars. You should all be experts in that by now, and register. Recordings and slides of all of our webinars are also posted at this same link. So now taking a look at the chat box. So Nora had asked if we could post the WAC, and Tim Gates thankfully went ahead and did that. It looks like he's posted a link directly to the WAC and also to Ecology's SMP guidance. And conveniently, both of these links are also found on the Coastal Planners website, coastalplanners.org/webinars, if you want to check them out later. So the next question, I believe, is going to be for Corey. Gwendolyn asks, what about shoreline bluff techniques? Biostabilization or intermediate engineering techniques are around, but don't seem to be used much. So what experiences can you offer about these bluff techniques? Corey?
I'd offer the difficulty with bluff techniques, which some of the items that we talked about are what you might consider bluff techniques. Things like resloping or revegetating is specifically a bluff technique, or the opportunity to relocate, you might consider that kind of a bluffy technique. The difficulty with them is they tend to be more difficult to achieve, I guess, depending on the scope and the size of the bluff you happen to be working on. But as you could probably imagine, working with the face of a bluff, which tends to be a somewhat steep and sometimes vertical slope, tends to be a lot more difficult than working on the beach, which is a little bit flatter, a little bit easier to interact with, and has a little bit more analog to the actual process. That's not the right way to say that, but the process that we are concerned with interacts with the beach pretty much always. However, bluff might be set back far enough that interactions on the bluff, interactions with the beach and to the process don't actually change the dynamics at the bluff. So you might have more success in interacting with that bluff in different ways, and more like passive techniques and things like that. And the other thing is that oftentimes what's driving larger bluff issues can actually be something that's really not terribly controllable in the case of subsurface conditions, or when if there happens to be more deep-seated landslide types of things. So biostabilization, absolutely. Intermediate engineering techniques, things where you're not full on just armoring the heck out of it, certainly, but I'd say that they're a little bit more difficult to achieve just considering the necessary scope and scale.
Great, thanks, Corey. And it looks like Tim's just posted another ecology resource related to surface water and groundwater management on bluffs, so go ahead and check that out. Brandy asked, can you display the entire chat record? So during the chat, yeah, you can go ahead and look at what's been said. Unfortunately, we currently do not have records of the chat posted on the Coastal Planners website. We do have the slide recordings and a PDF of the slides themselves with our speakers' notes. But if you have a specific question, like if you think someone said something and then you missed it, go ahead and email the three of us, the presenters. Our emails are shown here on the slide. And then if you had another question that you think maybe someone asked, go ahead and ask it again. We're happy to cover that and get you the info that you need. I think the next two questions are for Corey. So I'll ask the first one and then maybe he can cover the second. So Doug asks, if hard armor is a must, will breaking up the angles and shortening the overall length help?
Will breaking up the angles or shortening the overall length help? That depends. I mean, I hate to just keep deferring to that. It kind of depends on conditions answer, but in this case, I guess it really does. And the one thing I'd offer is that you'd want to minimize the necessary length, but qualify that minimization with make sure that you're not aggravating the problem at another point. I touched on end effects and wave reflection, and the difficulty in getting too super specific about your angles unless you have really, really, really good wave information at your site is that we tend to see a change in seasonality with how our waves interact with our shoreline. So that's kind of the difference between like net shore drift, where a drift which direction drift happens to be running, versus localized or short-term drift. So if you're adjusting or making angles a little bit more favorable for the prevailing winds, you may not necessarily. You could have some negative impacts on some of the more like the higher. What's the word I'm looking for? Some of like the higher winds that we get more seasonally that aren't quite as regular as your prevailing winds. And again, shortening the armor, yes, it helps, but I'd qualify that you want to make sure that you don't shorten things to the point where you are aggravating erosion at a certain location, unless it's 100% positive that that location can be considered sacrificial, in which case I suppose it's not necessarily a loss, but you know there is that chance of the end effect actually kind of working against you, and that the end effect will aggravate erosion on the downdrift side of your structure and can potentially ultimately cut back behind your structure. And then, you know, I wish I could show you photos real easily here, but you know, we occasionally see shore armor that's sitting out in the out on the beach where the bluff is receded well behind it, and then we just have this unfortunate situation where you got a big chunk of rock or a bunch of pilings just sitting out in the middle of the beach, not protecting anything. And then the next question here, if the shoreline is accreting, is it ever necessary to consider shoreline protection? I'd say yes. And it kind of, again, depends on your situation. If you've got a structure, say, or infrastructure, but say, let's make it easy, say you've got a home that happens to have an accretion shore form on the face of it, but that home has been experiencing poor effects of salt water interacting with their septic or something like that. So that might be a location where you have an accretion shore form, but you might consider putting something along the lines of a deformable berm, something that's made out of like some beach nourishment and potentially some logs that can help minimize that effect without necessarily impacting the process in that type of setting. So yeah, there are times when it could be necessary and helpful, but obviously not as critical if you're on a more of a transport zone or a bluff necessarily. So.
Great, thanks, Corey. It looks like as you were talking, Tim's just killing it. He posted another vegetation management link in the chat, so check those out. Let's see. So I'm not seeing any other questions in the chat. I'll give folks another moment to go ahead and put something in there. Otherwise, it's going to, be going once, going twice. So as we're wrapping up, just want to remind you again.
Wait, you missed one.
I did?
Yeah. If a shore is accreting, is it ever necessary to consider shore protection, or is that the one you just were doing?
Corey just answered that one.
Okay. All right. And I couldn't remember if there was one from up above that we missed earlier on.
Let me take a quick look. Folks, keep on typing those questions. I think we covered everything either during the course of the webinar or here at the end. If I missed it, shout it out in the chat, folks. We want to make sure to answer everybody's questions. So we'll leave folks a quick second to do that while I again remind you about webinar 4 next week about sea level rise, March 3rd at 9:30 a.m. You can register at coastalplanners.org/webinars and also see the recordings and PDFs of our slides with our speakers notes. So if you didn't quite catch something or you were like, what is that technical term that Corey was using? You can check it out in our notes. Also, we have a glossary available in that handout packet. I'm not seeing any other questions in the chat. So with that, I'll just say thank you again, everybody. You've been an amazing audience. Thanks for all your great questions, and we hope to see you next week for the 4th and final webinar in our series. Bye, everybody.